So what is electric circuit? Can you give me some idea? Yeah.
Ooh.
Yes.
Electric circuit is maybe the flow of charges through two terminals, one positive, one negative.
What about you?
I agree. The electrons go from positive to negative.
Okay, so let's write it down your idea. You are saying that electric circuit allows electric circuit is the path of charges from positive terminal, electric circuit from positive terminal to negative terminal, from positive terminal to negative terminal in a given
Time interval.
Okay, now we're gonna quickly draw the picture version of this one. How can you draw the picture version of this definition of electric circuit?
Maybe.
So we start with a triangle, okay? And what are we gonna put in the triangle?
Terminals.
Terminals. So we have two terminals, positive and
Negative.
negative. So positive terminal and negative terminal. What else we gonna have? We're gonna call it voltage. Voltage. What else we have? Current. Okay, so current.
Resistors maybe.
Current goes from positive to
Negative.
and
maybe.
And a resistor.
Mm.
Okay. Now we're gonna write the equation version of this definition of electric circuit. What would be the equation? Anybody?
V equals I over
I
R.
is equal to Q over T.
Oh yeah.
Right?
Oh.
Okay,
Yeah.
now I'm gonna draw a road. Okay?
So
This is a road.
yeah, King.
What is happening on the road?
You'll usually see the
Cars are
traffic
driving.
everywhere.
Okay, so
Traffic everywhere.
alright, so this is, we can call it, this is point A, right? This is point. We can call it positive terminal, we can call it
Negative.
negative terminal. Can we do that?
Yeah.
Alright,
The
so
cars are like the charges flowing.
so how can I measure the flow of car? Flow of traffic. Flow?
By seeing how many cars pass from A to B in a certain amount of time.
Is the flow of traffic the speed of one single car from A to B?
No.
Is the flow of traffic is the speed of one car from positive to negative?
No.
What is the flow of traffic?
The flow of traffic maybe is
I
This
think it's
car-
all the cars.
Not all the car. This car,
all the cars.
Oh, the number of cars
number of car.
between A and B.
The number of cars that passes between A and B in a certain amount of
Good.
Wow.
Number of car passes through A and B in a given time. Okay. What is the flow? What is the flow of charge?
Oh.
What is the
It's
flow of charge?
the number of charges that flow from terminal positive to terminal negative.
Okay. Number of
given
not
amount of
car.
time.
Number of charge.
Isaac, can we work together?
Number of charge passes
Yes, we can. Even if we build a path
pass through from
Positive terminal to negative terminal.
positive to negative terminal
in a certain amount of time.
in a given time. Let's say 140 coulomb. 140 coulomb. It takes 1 minute for 140 coulomb to pass through from positive terminal to negative terminal. 1 minute.
So
Okay, find the current. again, I'm going to explain it. It takes 1 minute for 140 coulomb to pass through from positive terminal to negative terminal. What would be the current? Quickly tell me.
140 over 60.
140 coulomb over
60 seconds.
60 seconds. If you have a calculator,
14 over 6
So that's
is
about
7 over 3.
2/3. So 2.6 or 3.
2.6?
Yeah,
2.6 amps. You must say the unit. Okay, now there is a question. What happened if I remove the voltage? Okay, this is a valid question. People always ask me what happened when I remove the voltage. Let's start with the Alex. What's your name? Alex?
Yeah.
Alex or Albert?
Alex, Albert.
Okay.
I think it's Albert.
What happened if I remove the voltage?
It stops the current.
Can you? It stops the current. Can you elaborate more? Who can elaborate more? What's your name?
Seizes.
Excuse me. What's your name? Isaac?
Isaac, yeah.
Yeah.
It seizes the current. It doesn't like slow it down. It just stops it. Like a lamp, and when you turn it off, it just suddenly boops.
It seizes. How do you spell seizes?
Ceases.
Oh, that's correct. So it slow it down. It slow down what?
It slows down
Correct.
the current and the
It
resistance.
slows down the charges. It slows down the charges. What slows down the charges?
Resistance.
Wait,
What? If no voltage, it slows down the
I
charges.
think I
Yeah.
know.
Yeah.
So
Why? Why it seizes?
the atoms have to break through. They have to break through the atoms in the wire that lets them pass through.
Okay.
And they constantly get supplied energy by the voltage. And when you take away the voltage, then the current has an unbreakable wall that they cannot pass through and just gives up.
Wait. There are other students in the classroom. You cannot be like, only person talking.
That's
Okay.
right.
So, Alex,
Yes.
Albert, yes.
So what was the question?
The question is what seizes? Oh my God! Okay, let me explain. What seizes the
Current.
not current? What seizes the
The circuit.
the charges? So this is made of what? Copper. The wire made of
Copper.
the electric circuit made of wire. Wire made of
Copper.
copper, and copper made of
Atoms.
atom. Okay, so the charges goes from positive to
Negative.
has to overcome the
Resistance.
barrier created by
Resistance.
atoms.
Oh.
The barrier that created by
Atom.
atoms. Okay, does that make sense?
Yeah.
If you remove the voltage, what happened?
They lose the battle with the atom.
They lose the energy. They lose the energy to overcome the barrier created by
Atom.
atoms.
See, that's what
Oh.
Very good. No, you said correct, but you are not only a student in the classroom, so
I see.
be careful. There are 34 students in the classroom, so you should not be only one person talking all the time. I know you should not be in this class anyway. Okay, so now another question. That question is, what if the temperature go down?
Oh, I have an idea. The resistance
If you have
goes
a
down
if you have a low voltage, how you can still light up the bulb?
by lowering the temperature.
By lowering the temperature. What happened with the atoms? If the temperature increases, atoms become noisy.
Yeah, they just move all over the place.
Creates the wall.
Yeah, and
Yeah.
it creates a very strong barrier. When they are still, they get like soggy, and the atoms can easily punch through them without losing a lot of energy.
If temperature go down, what happened? Atoms
Sleeps.
Yeah.
take rest. Atom take
Right.
Right.
So
rest.
they just
They
stand.
they sit on the couch, and sometimes they fall in,
Sleep.
or sometimes they take nap. When they take nap, why they take nap? Temperature go down, they sit on the couch, they take nap.
Yeah. So then it's easy for the charges to punch through them because they're not making noise everywhere.
With the small voltage.
Voltage.
Yeah.
So you can have less voltage.
Because the less voltage is still kind of enough to supply the charges with enough energy to break their barrier.
Very good.
Oh.
Now the lesson.
What were the other 32?
Our lesson is very simple today. There are how many? We already created the circuit. This is plus, this is minus, this is current, goes from positive to negative side, and this is the resistor. Okay,
What
there are
part
two
of the lesson is this? Can you write
lesson. There are two types of circuit.
series and parallel?
Yeah, series and parallel. How do you spell parallel?
Parallel.
Parallel.
Wow.
Series circuit. There are 3 rules for series circuit. Let's draw for series circuit. Well, I'm gonna give you the rules and you're gonna draw the series circuit.
I think
Okay,
that-
number 1, the current.
Has one pathway?
The current.
Has
Well, current has one pathway. Okay, current is same across the
entire
Circuit.
across. How do you spell across?
ACROSS.
Current same across,
Circuit.
circuit.
and then you're gonna write the math formula for that. Number 2. If resistor number 2 voltage drops. Number 3, if the resistor increases, the resistance increases.
Yeah, because resistor gives resistance.
Yeah.
So that's one of the basic.
Well,
What's
that's
the
not true for
resistor?
parallel. Okay, number 1, current not same across the circuit.
Because they're different pathways. So
Oh.
different amount of
Current not same.
because they're different pathways. So there could be a different amount of charges or atoms on each pathway.
Voltage same. Number 3, resistor increase, resistance decrease. Alright, now I want you to draw the diagram for series circuit and diagram for parallel circuit. You can pause the video and you draw it. Okay, now you check with me. The series circuit just like the one we have.
Yeah, just the rectangle, only one current pathway.
One path to the
Negative terminal.
one path to the R1, R2, R3. One path to the what? One path to the, so the electron has one, the charges have one path. An electron has one path. Does that make sense?
Yeah.
Electron carries the charge, so it can carry only how many way? One way. Alright, now let's draw it for this one.
A parallel would have multiple resistors
Pathways.
and multiple pathways. So like one,
So it would like branch off, right?
2,
Ah.
3, like this.
Yeah.
And then let's draw the positive
And then.
R1, R2, R3. Okay, now look what happened. The charges goes from positive to negative, right?
Yeah.
Okay, it goes over here and over here and it breaks, right? This path is break.
Okay.
Then this one will be what?
Broken.
Oh.
This one will be broke and this one will be broke. An example for this one is Christmas tree.
Oh.
Oh,
Christmas
so
tree.
the star at the top lights up?
If one light goes, if something wrong with the one light in a Christmas tree,
All of them.
all of them
Boop.
go out.
Because it's a series circuit.
It's a series
all
circuit.
in one line.
That's
So
right.
if the current fails in one, then it will quickly travel to all the others.
Right.
And in 1 second, bloop, no more lights.
All right.
Just like Christmas star.
Okay, so the charges starts moving and find that this path is broke.
Okay.
Currents, charges come back and try to find another path.
Oh.
And trying to find another path.
It's
So
like
there are
a.
multiple path of the charges.
It's like a maze.
Yeah.
It's like a maze or it's
Okay,
like
the resistors chargers are dead ends.
Example, home or office. Okay. Alright, the AC circuit that we have at home is a parallel circuit. Okay, now axis split. Okay, we're gonna have to write the mathematical version of this. Okay, we're gonna write the mathematical version of this tomorrow, but axis split is gonna be very simple. You told me that if you remove the voltage, what happened?
The charges stop flowing.
Yeah.
Or
The current ceases.
current ceases.
Right.
Okay, current ceases because the atoms create the barriers.
The atoms create the barrier, and because there's no voltage to supply the charge with energy, it's a permanent barrier that the charge just gives up on.
Mm.
Always just
So what do you call that phenomena?
resistor.
Resistance. What do you call this phenomena?
Resistance.
Can you explain it again? If voltage removed, if you remove the voltage, what happened?
Then the atom will become unbreakable in the wire because the voltage doesn't supply the charges with the energy they need to break the atom.
Okay, so this is analogous to what?
Oh, friction.
How do you say that?
Resistance is the electric analog of friction.
Good. Resistance is the electric analog of
Friction.
We talk about road, right?
Yes.
If you roll a marble on the road, what happened? Marble will eventually
Stop.
stops because there is a friction on the road, right?
The road is bumpy, so there will be at least some form of friction, and it's made out of concrete.
Friction. We understand friction, right? Thanks to
Yes.
Newton. We have a circuit. If you stop, remove the voltage, what happened? There is atoms. Atom creates the barrier, but the charges don't have energy.
To flow through
Charges won't have energy to overcome that.
barrier.
Alright guys, see you tomorrow.